This one I put together is on cracks and movements in building structures, which is a subject I've really been concentrating on for the last 30 years. Towards the end of the 1980s, early 1990s, there was a bit of a recession. I was actually working for a consulting engineer doing a lot of designs of office blocks and factories, portal frame buildings. The whole structural department virtually collapsed with the recession at that time. I was made redundant. But following from that, I joined up with a former colleague who was running a one-man business. He was getting a lot of inquiries from people. They would ring up, they'd say, "Oh, I've got some cracks in my house." I rang the insurance company. They said, I've got to get an engineer's report. Or it could be someone who wanted to buy a house. I found this fantastic house, I'm really in love with it, but the building society man's been along and he says it's got subsidence, I've got to get an engineer's report. So from that, we called the company Engineers Reports. We did a lot of work. Well, in fact, I sent a letter to a company in Swindon who I knew dealt with properties. Didn't exactly know what they did at the time. It turns out they were one of these relocation companies who move employees around for banks and people like Tesco's. They had a requirement at that stage for a lot of structural engineers reports because their valuers were going out and picking up problems with properties. They said we need them all over the country. We said, stretch the truth a bit, said yes, we can do that. We advertised for semi-retired part-time engineers. There were a lot of them around at the time, and we had this little network. The work came in and we basically handed it out to them all over the country. They'd do the report on a job-by-job basis. From that we expanded, we picked up some yellow pages advertising over the whole country, getting lots of inquiries. Then we sort of moved sideways into doing building surveys, home buyers surveys, drainage reports, electrical, all types of reports that are required. That went on very well for quite a few years. I think it was probably in the 2000s. I always remember it's about the time Northern Rock went down. The market seemed to be changing then, and I think it's the way people were getting doing their inquiries. They were starting to use the internet a lot more, and it was that time that we kind of established Local Surveyors Direct, so similar to engineers' reports but working in a different way. We were able to put the general public in touch with surveyors, engineers and the like throughout the whole country. Engineers' reports kind of faded away then towards the end of the 2000s, no longer exists as such, but Local Surveyors Direct is doing quite well. Is there anyone here who is not with Local Surveyors Direct? One. Okay. Right, going back to 1991, subsidence cover was first introduced by the insurers in the early 1970s. I think it's from pressure from the building societies. This was probably a good time. In 1976 was a heat wave. There was quite a big boom in claims then. And through the 1980s there was a lot of dry summers and winters. And the claims kept going up and up and up. Back in the early days, the insurance companies or loss adjusters would, well, the insurance companies might tell the homeowner who'd got a problem to get an engineer's reports. Sometimes the insurance company would appoint a loss adjuster who would then look for an engineer to do a report on it. Once the report was done, if they'd had identified it was a subsidence problem, it would carry on with investigations, trial pits, soil tests, drains tests and the like. Maybe a monitoring period, or this is all the type of work which we would do at that time. And then ultimately following it up with repairs, underpinning, design if that was required. Insurance companies have changed from that now. I think they got fed up with spending so much money on loss adjusters and engineers and all the heavy remedial works which were going on. They now seem to have their own people doing they seem to set up their own organisations to basically investigate claims. They'll do the initial inspections when it's required. They've got their own people who will do the investigations, and they've got their own builders who have got standard rates for doing all the repairs, whatever's required. Sorry. I'm not sure about the qualifications on these people. What they tend to do is to, sorry, just moved on to that slide there. Once they've gone through the period of inspection, investigation, and that, it generally comes down to a question of vegetation control if there are trees nearby, or maybe drains repairs. If they do any of that, they'd follow it up with a relatively short monitoring period and then give a certificate of structural stability. The certificate of structural stability is probably okay in terms of people who want to sell the house, people who want to get a mortgage on a house if they're buying. It's not a guarantee that the building is stable or it's not going to have any more problems, and I have come across one or two cases recently where a certificate of structural stability was issued around 5 years ago in one case, and cracks have appeared this summer in exactly the same location as they were originally. Not quite sure how these people who investigate it for the insurance companies work, or whether they have anything like professional indemnity insurance. I think they probably don't. I think they're just basically underwritten by the insurers with an agreement that if it's wrong, they get it wrong, the insurers have to come back and deal with it, then they will. Overall, it probably saves them money. Yeah. Okay. It's not a very satisfactory situation at all, and the feeling for the general public is that most of the claims do get rejected for any reason that they can think of. Looking at subsidence versus settlement, because a lot of the reports that we do emanate from the fact that people are concerned that they've got subsidence. And subsidence and settlement are both have the same impact on a building, but the causes are different in both cases. This is the definition of subsidence from the Zurich insurance company, which I found the other day on their website. Subsidence is the downward movement of the ground beneath the building other than by settlement. Very kind of simple and quite wide-ranging. One exception, settlement. And the definition of settlement, they say, is that it's the downward movement as a result of the soil being compressed by the weight of the building within 10 years of construction, which is, I don't know where the 10 years come from. I can only imagine it's something to put it in line with perhaps the NHBC guarantees, which generally last for 10 years. I think engineers wouldn't necessarily agree with those definitions, but it's a different definition. Probably more accurately in terms of defining subsidence. Subsidence can occur when the ground contracts, when the moisture is sucked out of clay soils particularly. And there are other factors such as leaking drains and softening clay soils, washing away sandy soils, decomposition of peat, mining activity, although we get very little of that these days. Okay, we've got an inquiry which has come in from someone. Nowadays it's more likely someone who wants to buy a house and there's some cracks in the house. Occasionally it's a homeowner who's just simply concerned that they've got cracks and it might be subsidence. Sometimes they're very so concerned as to whether the building is going to be safe. Is the ceiling going to fall down and kill my children or something like that? You know, it's surprising how people can't assess themselves the sort of degree of seriousness with some of the cracks. I mean, some of the cracks I look at are very, very minor and really laughable. I think I'm wasting my time, but that's what they asked for. How do we go about inspecting the buildings then? Obviously, as you walk up to the front door, you have a good look and you get a general impression. Ring the bell, speak to the owner of the property. When was it built? How long have you lived here? Were there any structural problems or concerns when you bought the property? Have you had any structural problems or concerns during the course of living here? Were you even aware of the cracks I've come to look at today? How long were they there? Are they getting worse in your opinion? Anything like that, just to get a general picture of what's happening. Then we start the inspection, looking first of all externally. Looking at the roof and all the elevations. Is everything level? Are the corners of the building plumb? Do the elevations lean out or in? Any distortion to the door and window openings? Any cracks? Generally, we'll have a clipboard, do a little sketch of the elevations, note down any defects like that. Go around the building. Always use a spirit level, which is quite useful because sometimes there can be slopes on bed joints which you can't detect with the eye, but with a spirit level you can pick them up. And maybe that may only be a slight out of level, but if that might couple up with some other issues, might lead you to see what's going on. Have a look around the surrounding area while you're outside. Are there any trees nearby? Are there any drains nearby? Do the neighbouring properties perhaps have similar cracking? Then you go inside the property, go through the same process. Are the floors level? Is there any distortion to the door openings? Are there any cracks? And again, note this down on notepads. From that, we then prepare a report. We call it a specific structural inspection. We will sort of specify what the problem or concern is. It can be very specific, like cracking to the front bay or cracking to the rear extension. Sometimes it's more general because you can't actually find out beforehand exactly what it is that they are concerned about, other than, oh, there's some cracks and movement in the building. Section in the report would give a bit of history, the background that you picked up from the homeowner as to whether there's any problems there in the past, whatever. Detail all the things you've seen, obviously listing the defects, but also listing things which are okay. If they're okay, you know, say the bed joints are true and level, corners of the building all true and plumb, things like that. And then conclusions and recommendations. We've really got to the reports we do generally tend to be the sort of the backstop on looking at a property. Surveyors and valuers have been along, they've seen cracks, they're concerned. They won't say yes, it is a problem or it isn't a problem. In many cases they're not allowed to by their employers. I recall once I had a surveyor from NatWest. I went to see the property. I can't remember what the problem was now, but it's very minor. I spoke to him and said, well, surely it's blindingly obvious what's happening here. It's not a problem. And he said, yes, I know that, but I'm not allowed to say so. So basically, don't like to say it's passing the buck down, but basically our reports have got to be the end. We've got to say, is there a problem or not? If there is a problem, we've got to say what needs to be done about it in terms of further investigations possibly, or repairs if it's obvious what repairs are required. Report goes to the homeowner then. The other thing which we really need to consider in terms of coming to the conclusions in the report is the severity of the cracking or movement, whatever's happening there. Is it affecting the structural stability of the building? That very rarely happens. I think I've got one slide in here where there is obviously a quite serious structural problem with a roof, which could collapse. But generally speaking, cracks and things in the building, they're never so severe that the place is going to fall down. This very often is a great relief to the homeowner who's concerned he's got some cracks and he wants to know if it's safe for his children to sleep in this bedroom because they're worried something might collapse. The second category down on severity is serviceability. Is it affecting the use of the property? Generally speaking, probably not, I would say. It does occur in some cases, but not a huge amount. I mean, in terms of affecting the use of the property, you'd have to have the floor sloping quite a lot to be of concern in terms of the general use of it. Although I might be extra sensitive to this now. I mean, I've go into a room and you can walk across it and you can actually feel a slope on it. But then the people have been living there for 20 years didn't even notice that, for instance. Door openings, if they're distorted and the doors won't open shut or windows won't open shut, that's a serviceability issue. And then the lowest category is the appearance. Is it affecting the appearance of the property? Well, obviously if there's any cracks, they are affecting the appearance, but to what degree and how serious it is and how concerning it is. Some people live in houses with quite significant cracks, they don't even notice them or are aware of them. Then other people, very sensitive, they've got little hairline cracks in the walls of the living room and they're concerned about them. So we generally need to sort of make some reference to that in the conclusions of the report. The other important thing with any cracks or movement is it progressive? A lot of the stuff I look at, probably most of it, tends to be stable or fairly stable. Certainly if it is progressing, it's progressing at a very slow rate. Obviously if you've got something which is progressing at a significant rate, then you've got a problem and we need to do something to stabilise it. If we have got a problem, and generally this relates to subsidence problems, you're going to need to do some investigations. You want trial pits to determine details of the foundations, how deep they are, get a soil sample from immediately below the foundations. You may need to do some hand augering to get soil samples at deeper depths. If you're going to be thinking that you may need to underpin to a greater depth, you need to know what the soil is down there. Soil samples will be taken off to a laboratory for testing and analysis, largely to determine how the shrinkage potential of clays, soil samples. If you've got sometimes properties built over landfill sites, these tend to be very deep-seated problems, and you could end up doing boreholes with big traditional boring rigs, but then you're probably talking about going down 5 to 10 metres. Whilst on site doing the trial pits and things, you would get the drains tested, maybe a CCT survey which will show you lots of cracks and things. It doesn't necessarily tell you what you need to know. Are the drains watertight? Are they leaking in a point near the building? So hydraulic testing of the drains is just as important, if not more so. You may need to do some monitoring to prove to the insurance company that the movement is progressive, if it's a sort of subsidence claim. If you're not sure whether it's progressive, you might want to do some monitoring to see whether or not it is progressive. If some remedial works have been carried out, such as the insurance companies do at the moment, like you've got a problem, okay, reduce that tree by 30%. They'll then monitor it for a few months, say it's not moving and it's all okay. Once you've got a situation which is stabilised, sorry, too fast, you might want to do some remedial works. If it's a subsidence case, it could be a question of underpinning if you can't deal with it by vegetation control or drains repairs. Got a few examples here of properties with subsidence, and sort of this is the sort of first stage of going in to do the inspection. So walking up to this house here, end of terrace or semi-detached, I think. First thing you notice, obviously, there's a significant tree close to it. It is autumn, so it's lost most of its leaves. In the summer, it would look a lot bigger than it is. Yeah, there's a path down the side there. So going down the path down the side, you'll see there are all these stress cracks in the path. This is where this area I know is a shrinkable clay, because I've checked on the geology map before, or I've got local knowledge. The shrinkable clay, obviously with the tree there, is shrinking the clay sideways, horizontally as well as vertically, causing these cracks. Further up we can see this is the problem area. Before I actually go and look at that area in detail, I've probably been in the property, got a bit of background from the homeowner, told me, oh, there's cracking at the back, you know, we've tried repairing it and it's getting worse. So this is the back corner. We can see there we've got the garden wall, which is built into the house wall, which is bad because when the garden wall moves, which they often do compared to the house, they also damage the house at the same time as they pull apart. This is obviously moved in the past. So you can see we've got all this has been repointed. And it's obviously in the past it's damaged the brickwork up here because this has been repointed in this area. The repointing down here has re-cracked, so this is obviously continuing to move. The tree is obviously the number one suspect for it. There's also some repointing here and here. There's a particular problem in this area, so on close inspection, there's a big void underneath the wall, so the foundation beneath there has dropped and that sort of corner of the wall is just basically hanging out there in mid-air. Pretty clear that's a subsidence problem, and the next stage would be to go on to do trial pits to see how deep the foundations are and what needs to be done in terms of probably underpinning for that one. This house here was extended. We've got a two-storey extension. It had only been built about a year before I looked at it. Massive trees on the plot next door, and it's a very heavy clay. As I walked around the back garden where they got all sorts, it hadn't been reinstated, the back garden hadn't, it was just a mud bath. Clung to your boots like anything. It was really heavy clay. It should have been pretty obvious to the builder that it would be a shrinkable clay, and you've got trees nearby and you'd have to have quite deep foundations. The foundations are actually 1.2 metres deep for this, which is wholly inadequate. How they got it through building control, I don't know. But going to the front, you can see there we've got a movement joint between the original house and the extension. Looking at the front extension there, we've got cracking here, we've got cracking here and cracking there. The lower cracking you can see as it goes higher it gets wider, and then the cracking between the windows, again increasing width with height. It's quite clear that that front corner, there's cracking at the top as well there, that front side is subsiding and pulling away. Round the back of the building there's a movement joint there which has been repointed. That's excessively wide for a movement joint of any sort. You get an idea of the kind of movement with the east soffit there and the gutters pulled apart. The people there actually called me in because they were not getting anywhere with their insurance company, and I think quite rightly the insurance company deemed it to be a design fault. So the extension was only a year old, and he said, gone like this. That would have needed serious underpinning, but I don't think they could afford it. This is just a bit of cracking inside, which would be a particular problem there. I would be concerned about that. It's telling me that this back part of the building here is definitely dropping. This crack here starts narrow and gets wider. This one here is narrower at the top and gets wider at the bottom. And this block of brickwork in here is effectively, because if that's the brick where the two crack lines are roughly, sorry, as this side's going down, it's going like that. So you get the wider crack there, narrower crack there. What have I done?
Mike, just a question on the foundations. Instead of 1.2 metres, is 1.2 metres on the house and the extension are the same, or are they different?
I don't know what they were on the house. That had been built quite a few years earlier. All I got to do on this one was basically do the inspection. They told me the foundations were 1.2 metres deep. Did the report, and like most of these jobs, I never hear anymore, so I don't know what happened. So with this one, we're dropping down in this area, and above the window, there's also similar cracking there. I'd be concerned about that one, that it has got an ongoing problem because it's fairly recent cracking. That's quite clear there. So those were definitely subsidence problems. Few examples here of settlement, which, as I said, you've got the same symptoms on the building, but the causes are somewhat different, and particularly different from the insurer's point of view. Older property here. You can't see it on this one, but on the next slide you can see with the bay, the whole of the bay, in fact the whole of the front elevation has dropped down here on the right hand side. You've got, I'd normally put a spirit level along here, which would obviously show me how much it is sloping. You can see the difference in height there to there, and similarly on the window heads as well. This is definitely settlement because there wasn't any cracks at all on the building, no repointing being done recently or anything like that. That's been there for a long, long time, and it's not getting any worse. This is another case, a lot more severe actually, the way that slopes down to the left. It's all rendered and painted, again no cracks. Definitely long-term settlement, which is now stable. Internally, this is a very distorted door opening. No cracking above the door opening, no opening of the architrave joints there, which would indicate that there was ongoing movement. The door's been cut to the opening. Long-term movement, settlement, no problem. And this was an unbelievably severe one. You get the impression there that they've actually put the lintel in a brick course higher on that side. You just can't believe your eyes on it. And it's the same on that side as well. That one comes down. I can only think the party wall there is a lot heavier than the front elevation structures and has settled down considerably for some reason. But again, no cracks or anything evident on these. Sometimes with older buildings you do get little bits of foundation movement. It's not settlement, it's not subsidence, it's what we tend to term seasonal movement. This is probably 100-120 years old, solid brickwork, probably with lime mortar behind it. It's all been rendered to make it look nicer, but the trouble is the render is a lot more rigid than the old brickwork, so you get a little bit of movement on the structure, and you'll get the cracking of the render in places like this, here and here. Bit one going through there as well, various places. These cracks are going to be impossible to eliminate completely. All you can do is fill them and decorate them from time to time. It's a maintenance issue. They're never going to get significantly worse. So that's subsidence and settlement, but there are a lot of other causes of cracks and movement in buildings, which I'm going to run through various ones now, and other structural issues which tend to arise quite commonly. This property here on the left, the lady wanted to buy it. The surveyor had been along. He said it's got a bit of cracking, there's very pointing here, cracking here, cracking here. Looks like it might be subsiding. The side to this side, it was just a car park. There's no trees or anything significant there to cause subsidence, no drains even on that side, so it was a little bit puzzling there. Looking at the cracking under the left side bedroom window, you can see it's been repointed in the past. There may be some slight re-cracking there, but not anything too significant. Above the window opening, there is cracking there. The lintels, the brickwork there is dropping out because of the movement. It's not huge wide cracking there. It's never been repointed though. And to the right-hand side, we've got an area which has been repointed. No cracks to that. The repointing of that is different colour mortar to the other repointing, which suggests it was done at a different time. Looking again at the front elevation, the next door property, we've got a bay here and a porch there. Undoubtedly, this had a bay here and a porch there originally. I'm guessing that there was a timber beam across the bay opening, probably damp got in and it rotted away. So there would have been cracking and disturbance of all this brickwork in this area. That's pure guesswork. The owners at some time decided, oh, let's get rid of the bay, let's get rid of the porch, let's extend it forward the whole width of the building and put this lovely little, I don't know what you call it actually, in front with a nice flat roof. In doing so, they also took out this bit of the front wall, which would have been in this location, and put a beam right across here. And my conclusion was that the movement of this brickwork when the beam over the bay failed, and the propping up and everything when they installed this beam and took this wall out internally and built this extension on the front, disturbed it and caused this cracking to this area and this area. I think they probably repointed the cracking there because they could just get on the flat roof and do it easily. That one is a bit too high up, so they didn't bother. That seemed to fit in with everything else because this wall was plumb, the bed joints and everything was level there. There was no other signs that would indicate that it was subsiding on this side of the property. I think that you went ahead and purchased that quite successfully in the end. This is another one. Standard sort of house where you've got a side entrance and the stairs go up in the middle of the building with a front room and a back room. In this case, the stairs are they're set back a bit and they turn around on themselves, so you've got a bit of an entrance hall which is like 2 stair widths and then wall to the front and back of it. For some reason, the owner decided to widen this door opening. I really don't know why, but it seemed to trigger off a whole load of problems then. Inside, this is in the entrance hall looking towards the rear. He's got cracking here, which closer up you can see the architrave has opened up. The cracking extends up there, all the way along the ceiling. And on the entrance hall looking to the front of the property, we've got the similar issue. Again, closer up, cracking there, all the way along, and goes along the ceiling. The first floor joists in this property go front to back, so they're not providing any restraint to the side wall. And basically, I think as a result of him widening that door opening on the side, it's kind of triggered off some movement in the building, some lateral instability to it, and the side wall is moving out. And I think the solution in this case was to put in some restraints through the wall into the floor joists. People like Halifax have standard systems for doing that now. Bay windows. These are very often fragile structures. They stick out from the buildings. You often get a lot of problems down at this level because the foundations of the bay are very shallow compared to the foundations of the house, and they tend to settle more or sometimes subside more. That will cause cracking up here and on the side walls, and that'll go all the way up the building. In this property, which is in North London, been totally refurbished to the extent they must have sandblasted or jet washed the whole front elevation, repointed it all, and it was immaculate inside. Only problem is there's a problem up here. Looking at the bay closer, you can see how it bulges out considerably there. This one also bulged out the same amount, if not more, and the brickwork over the opening there sagged down considerably. There's no specific reason why this had happened. It's just one of the basically aging wear and tear on the building. It's got a simple flat roof, so the roof couldn't be pushing out, causing it. Why they spent so much money doing the property up so nicely but didn't deal with a serious structural issue in the first place, I don't know. But my only conclusion on that one, our only recommendation on that one, is they'd have to rebuild all this from this level upwards. There's no specific cause, as I say. A lot of bay windows were built with the wooden frames being load bearing, so the ground floor ones supporting the first floor structure and the first floor ones in turn supporting the roof. Problems very often occur when you change the windows to the plastic ones, which happened in this case. Must have been totally incompetent installers, because they'd replaced both sets of windows, the ground floor down here, and they'd replaced these up here. In doing so, they hadn't really taken into consideration that the original frames were load bearing. And a lot of movement occurred in this area and up here. They put in some props there, which is probably in that position is actually doing no good at all. But the movement was considerable. That sort of movement is quite typical. But in this case, there was considerable dropping at the top of the window, to the extent they'd put their cure all expanding foam in the gaps. Again, doing absolutely nothing. The only solution to this one is totally rebuild the bay, I'm afraid. This isn't quite a bay. This is the only one which I say there's a structural stability issue here. I was asked to do a report on this. There's some sagging of the roof over the bay. Again, it seemed quite a ridiculous one, because it's pretty obvious what's happening here when you just look at it, and then you go to the side and you see it's all collapsing. The timber is probably damp. I'm guessing damp's probably got in on the valley gutter there or something, or maybe they've got dry rot or some particular problem. Again, the only solution there is rebuild it. Simple report to do, really. What they really needed is perhaps a design for the rebuilding. Oops. Conservatories and extensions. These are always a problem in terms of movement relative to the main buildings. This particular job I featured in when I did a talk on conservatories in 2006. The paper is actually still on the local surveyor's direct website, and I think 2 or 3 times a year I get phone calls from people from various parts of the country who have actually got problems with the conservatories and want some free advice. But this is a house in Epsom. It was a new house. As soon as they moved in, they had a conservatory built. There's a nice oak tree here, very close. They should have known it was a shrinkable clay from the locality of it. The foundations were about 0.7 metres deep, and within a matter of months, the first summer, we've got gapping where the side walls of the conservatory join to the main house. Fortunately, they're not built in, so they're just pulling apart. That is fairly common. The lady there was rather peeved because the insurance company didn't want to know about it. Again, it's a design defect. The builders who put the foundations in should have known what they were doing. The only problem with conservatories is you don't need building regulations for it, so the building inspector wouldn't have gone along there. I guess some jokers who did doing the work didn't know what they're doing. But to anyone in the know, it's pretty obvious with the clay, soil and the tree there that you need exceedingly deep foundations. This is slightly different. This is a much older property and an older extension. No trees here. There's nothing out here which could cause subsidence to the place. But where the extension and the main house join, you've got a tapering crack. Fortunately, again, they're not bonded together, so it's not causing any damage to the house in this case. That crack will be reflected inside. Over the years, property is decorated inside, the crack will be probably filled and painted over. Externally, nothing's usually done to them unless they can be bothered to do a bit of repointing. That crack, I think, would be just progressing at a very slow rate, certainly not fast enough to do anything major like underpinning or deepening the foundations. It just wouldn't be worth, you couldn't justify the cost. This is an area where cracking very commonly occurs. In fact, I'm almost beginning to think it's normal. It's in like the Victorian terrace properties you get, particularly in London. Top of the stairs here, you get a vertical crack going through the party wall, from the stairs up there, right up to the ceiling, getting wider as it goes up. Very often it's caused because the front part of the house has got a coal cellar with relatively deep foundations. The back part of the house just has ordinary, very shallow foundations, particularly in terms of the Victorian ones. Although it also happens sometimes when you don't have the coal cellar, and I've never quite figured out why. Is there a particular reason on that? If you, that cracking there, I mean, that is old wallpaper, you can tell from the design. No one would buy that these days. That's probably taken 30 years or something for that crack to come through on it. So typically that sort of cracking in that location will get decorated over on a regular basis and not present a particular issue inside. If you look in the roof space, you'll find a considerably wider cracking. That one is not too bad. I've got another one in a minute actually, but this is also cracking in the same location in another property, but this property has been nicely decorated fairly recently, and they tell me this cracking has suddenly appeared and progressed over a matter of weeks during a dry summer. So this one I'm concerned about. The probably the back of the back extension is subsiding. Probably there's trees or something at the back, that's the usual cause. This is, actually this property was demolished, but it exposed that party wall at the critical location where they've got the main house and the back extension. You can see here, this is first floor level. You can see where the crack goes, which up to ceiling level, which would have been plastered over, I say regularly decorated, regularly filled and decorated over the years, never created a great problem inside. But then in the roof space here it's quite significant. They've actually stuffed some newspapers and plastic sheeting in there just to fill the gap between them and the neighbours. Right, the owner of this flat-roofed flat in Southampton was concerned that he'd got cracking at the wall-ceiling junctions. It wasn't particularly severe, although it was quite extensive. It was where the ceilings hit the external wall all the way around. It was quite noticeable actually. It was definitely a cosmetic issue, I would say. What's happening here is the flat roof is going to be subject to big temperature changes when the sun's on it in winter. Expands and contracts regularly. The cracking is going to always occur at that junction. It's impossible to get rid of it completely. Best bet would perhaps be to put up some coving to try and hide it. Brick shrinkage, this is often confused with subsidence in the first place. This particular colour brick seems to be susceptible to it for some reason, don't know why. Long run of brick between the front and the back corners, and it will expand and contract. This one particularly tends to contract or shrink away. We've got cracking at this location, which typically zigzags through the mortar joints all the way down, and very often is repointed in a contrasting mortar, so it shows up even more than the original cracks do. That's the side we could see before, and this is the other side of the building. There's only one window opening there, which is at high level, but again you've got the same figure going all the way down. Brick expansion. This is a little brick wall on top of what is a small retaining wall. The ground level beyond it is slightly lower, not a lot lower. When I first saw this, I thought maybe a vehicle had hit it, knocked it in, cracked it. It looked very bad. But when you look at it close up, there's no lateral movement at all of this. What's happening is you've got this long run of brickwork here. At this end it goes round a corner and it can't expand anywhere. This end is also buttressed with a return which won't move or go anywhere. So the brickwork in between, it expands, and as it pushes together it buckles upwards. That's quite severe though, the amount that's happened on that case.
Why does it expand? Is it temperature?
Temperature and moisture, I think. Yeah, I mean, and also sometimes you can get, if you get shrinkage of it and it opens up a crack, what happens is the crack opens and little particles of the sand from the mortar will drop into the crack and block it. So then when it tries to go back to its normal length, it's jammed effectively, and that puts it under stress as well.
Is that the same for the shrinkage, that the moisture is changing?
I mean, in some cases you just get the shrinkage, which is a natural shrinkage of the material, and it doesn't return. Yeah, expansion of brickwork tends to occur in long runs where you've got this terrace. I haven't got a picture that this terrace continues on a long way here. This band of brickwork between the upper and lower windows. We've got some cracking in this location which is quite noticeable, as you can see, been repointed in a nice contrasting mortar again. In situations where you've got an end, there's a return here, so this long run of brickwork here can expand and push this way. What you get on that end then is, I don't know if you can see it well on the slide, it's a faint uniform width hairline crack running up here. It always occurs the thickness of the outer leaf brickwork position, because this face here is pushing outwards and it somehow snaps the bricks. Blockwork shrinkage, these types of blocks, the insulating ones, they are particularly, they shrink but don't expand back. So you get, again, difficult to see, but you get a vertical crack. They're so weak it will go straight through the brick, so through the block, crack them, and fairly uniform width throughout the whole height. It perhaps fades out at the bottom a little bit, maybe fades out at the top. The manufacturers recommend that you should have movement joints every 3 metres in this, but in domestic work, residential work, it's very rarely incorporated. So you see these cracks inside, mainly in the garage, attached garages. Concrete lintels. Now, concrete also shrinks, only a little bit, and over the long term, and this leads to problems with the supports for the things. We've got concrete lintels over all the window openings here, and there's cracking at the end of all of them. You can see a little bit of gapping at the end there where it's shrunk away from this brick, and then the bricks which it's resting on have been pulled over, causing the cracking, which extends all the way down here and into the return a little bit. Nothing you can do about that, it's just a natural thing with the concrete. Case like that, I would recommend cutting out those bricks and replacing them if you can, and raking out and repointing the joints. No lintels. There was a time when a lot of the houses were built with no lintels on the outer leaf. The outer brickwork was built off the wooden frames. When they're replaced with the plastic ones, you get problems. As you can see here with this particularly wide patio door opening, we've got a bed joint, 2 brick courses up, has opened up, all this brickwork's dropped and is loose. It's now resting on the plastic, which isn't designed to support it. Sometimes it's the whole sort of triangle of it drops, you get cracking stepping up from both corners. In this case it's been repointed, but again this is all loose. Quite a hefty chunk of brickwork actually bearing onto that frame. Next time they replace the windows there, they'll have a bigger problem. These can be remedied by putting in bed joint reinforcement across some of these beds, across the opening there, which forms a sort of beam, a structural beam within the brickwork, and then you can also drill up and pin the lower brickwork into that. Otherwise you can take it all out and install a lintel just for the outer leaf. Similar situation occurs where you've got this very shallow arch brickwork, particularly close to corners, with a little bit of movement on the building, which you'll get on an old building. The corner perhaps moves out fractionally. It relieves the pressure on the arch, which tends to drop, and also causing cracking up here and here. This has all been repointed and is okay. This has been repointed in the past but has dropped again, I think as a result of the works to replace this window, which looks like a new window. You can still see the expanding foam, which is probably just, this is probably just actually holding this lump of brickwork in place now. That one, definitely a case of having to take it out and rebuilding it. Steel garage door openings here, steel beams across them, no paint or protection on the steel at all. The steel begins to rust, and where it's bearing and sported into the brickwork, it lifts the brickwork up. Obviously, when the steel corrodes, the rust takes up a much larger volume than the original steel. That pushes the whole parapets up in this case. Similar situation here, we've got a handrail which is starting to rust where it's buried in the brickwork there, and we've got cracking there and cracking down here, pushing all this brickwork out. These are all problems which people sort of look at, they see these cracks and they think, my house is falling down, is it safe? Chimney breast removals, I get to look at quite a lot of these actually, probably because in the past people were a little bit sort of reckless in the way they removed them. This situation here, I've got some modern blockwork there. I think this is a party wall, and originally there wasn't, the party wall didn't extend into the roof space, so they've put this blockwork in there to block it off as fire protection. But they've removed their chimney lower down and supported it on a couple of planks and a couple of bearers onto the ceiling joist this way. Doesn't look too bad on this side. If you go around the other side, it's all starting to fall off. This is probably not going to fall off and cause any great problem, but the fact that we don't actually have an original party wall all built into it does give me some concern as to what's holding the rest of it up and how long it might stay up. This one was quite alarming actually. They removed the chimney breast. This piece of timber here is actually part of the roof structure, a tie, but the chimney breasts remaining are support. You can see the lower edge of this timber underneath it and three sort of diagonal types raking struts there holding it up. That one was actually quite scary, sort of taking it out halfway between sort of the ridge and the bottom. Structurally there's no way you could actually put any numbers to it and justify that it would stand up like that.
Isn't the guidance that you have to leave the same amount above the roof as below the roof?
I've not come across that one. There is actually a very good sort of building control, building regulations people. They've got a sort of a association type thing, and they give advice on various things. And there is a very good little paper on what circumstances you can remove chimney breasts safely and how they should be supported on that. Generally with these, what they say is you've got to have the ones where they come down and they sort of meet together like this, and various ways. But there's a lot of details in there on it, but I've not come across that particular rule. Gallows brackets were used a lot in the past to support the remaining chimney breast, and you can justify that by calculations to a point. The difficulty is the fixings here and here, particularly when you're dealing with the old Victorian buildings with fairly weak brickwork and lime mortar. You simply can't get enough anchorage of the bolts into that brickwork. Most London boroughs now will not allow gallows brackets under any circumstances. They seem to be working in this case, but then that looks quite good brickwork actually. This one's got gallows brackets which seem to be doing their job. The only problem is that all this bit of chimney breast here seemed to have fallen off and is down here. And we've got some cracking here, so this bit is probably about to fall off next. I think the weight of that, plus the weight of that on falling onto it, will probably definitely go through the ceiling. So it is one way you wouldn't want your kids sleeping in the bedroom below. It amazes me they actually did this. This is part of the original construction, and these always seem to work. This is a usual case where I think you've got a kitchen which had a solid fuel cooker or something, and then it would come up to a sort of flue inside the building, which would come and then come up on the outside of the building. Never seen any problems with that type of thing generally seems to work well. That one projects out quite a reasonable distance. This is another one, comes out 1 brick width, all fine. Then this builder told me about a chimney breast which had fallen off the outside of a building one day, and since I was driving that way I took the opportunity to stop and have a look at it. This is quite high up actually, I think it's about 2 stories up. It only projects out half a brick thickness, but there's a hell of a chunk of it going out. It wasn't a job I was actually involved in, but I took a photograph of it and I picked it out actually for this presentation, and it was only last night when I was looking at it very carefully that I think I realised what's happening here, or why it's happened. This flue here is very quite distinct, where all the soot is. Around the edges, all clean water or brickwork. This one, you see we've got a bit of soot here coming out to the side and a lot of soot there. Seems to have affected all this. So I think the flue lining on this side has broken down. The hot gases have leaked into the brickwork over the years and weakened it there. And then the weight of all this chunk of brickwork couldn't be supported by the little brickets at the bottom, and the whole thing just collapsed one day. Roofs.
Back to those flues. Why do they not extend above the roof line? If you go back to the one before. There's a vent. The one before that. Sorry. You see how it goes on the.
I think they probably chopped it off above the roof line. As I say, it would have been a solid fuel cooker or something like that, which would have been taken out, so they wouldn't need it. That would have been my guess.
I've inspected one recently where they rebuilt the top of the flue, and the original cast iron gutter runs across it, so it must have been like that, constructed like that originally. It's very strange.
Yeah. Yeah, I would definitely say that is original. Yeah. Roof problems, I guess has to look at these from time to time, usually because there's some distortion such as this. You can see how it's obviously sagged in here. We've some weakness in the internal structure. This is a very old property and it's probably been like this for a long, long time. There's obviously rooms in the roof, as you can see from there. Can't remember the details on the inside on that one now. This one is not quite so severe, but you can see hogging over the party wall line and sagging in between 2 roof lights there. They probably removed some, either the internal purlin or the struts to the purlin there, which has caused that. In those cases, it's always a question of really, you can do a report to tell them what the problem is, but they can see that for themselves. The reason is because the roof structure is just not adequate, and the main thing is actually to recommend what needs to be done in terms of strengthening it. This is some internal cracking which was actually caused by a roof problem, strangely enough. We've got a crack there and a crack there, and what's happening is we've got the eaves along here. It's a situation of roof spread where the feet of the rafters are not adequately connected to the ceiling joists and they pushed outwards. Many cases it just pushes the eaves sort of fascia and soffit out, and you can see that from the line looking up the outside wall. But in some cases it can push the top of the wall out, which is what's happened here. And the cracking at the side there gets wider as it goes up. And we've got a crack here. The wall above here actually leans out. You put the spirit level on that and you can see significant outward lean on that one. That was a bit more tricky of a problem to deal with, because you really need to consider rebuilding part of the back wall. This is a house which has got problems with the truss rafters. Unfortunately, I couldn't get into a position on this one where you can actually see the tiles on the outside. If you did, you might actually see the sort of a waving line as they go up and down the roof slope. But inside the roof, it's a difficult picture to do. That's one of the verticals of the truss rafters. This is the rafter itself, and it had got a significant curve on it. It was probably built, I would think, the late 60s, early 70s, because I think the British standard came out in around 1970 on the use of truss rafters. A few of these problems occurred, and the British standard was updated twice in about 2 years to include bracing on the underside of the rafters and ties, binders across at the node points there, basically to restrain that point from any lateral movement. Carbonation of concrete. Cement, which is the main constituent of concrete, is alkali, and when you've got steel reinforcing bars in the concrete, this alkalinity of the cement protects it against corrosion. Over the years, the effects of atmospheric carbon dioxide and acid rain will cause chemical reaction and neutralise that natural alkalinity. It takes many years, even decades, to work its way in from the surface of the concrete to the point where the steel reinforcement is, but when it gets to the steel reinforcement, then it can begin to rust, which very often happens in older structures, particularly if the amount of cover on the concrete is small. When the steel rusts, it expands and splits the concrete off, causing cracking. This is a school building. We've got 2 levels of classrooms, and up here is a sort of sports hall theatre. It's a concrete frame building. These are concrete columns and some concrete ringed beams there, and then a bit of brickwork infill and cladding. There's the typical problems with some of the concrete spalling off, like the previous ones, onto the surface. But there was a particular problem I asked to look at on the inside of this building at the location of these columns here. This was at the back of the stage of the auditorium. The window level is up there, and there's this cracking down the columns which looks very much like the reinforcement is corroding, which is unusual because it's inside the building. This white stuff is effervescence, so obviously water's getting in somewhere here. Looking out of the window, that's the face of the column, these are the sills, and we've got this big gap here which was probably filled in with mortar or something at one stage, but it's not there anymore, and clearly what's happening is water, driving rain is hitting that surface, it's filling this up and gradually leaking into the building, and it's caused that carbonation of the concrete on the internal columns. That's quite an unusual situation there. Steel frame buildings, on the outside they look like a normal building basically, in most cases. Building societies and banks will generally lend on them these days. They used to be very averse to them. They will lend on them if the condition of the steel frame is looked at. The problem with the steel frames generally is the base of the steel columns in the walls, which tend to corrode in certain circumstances. What we do in those cases is take some bricks out and actually have a look at the condition of the steelwork. Probably the most common type is this one, it's truss steel. These are the rafters, they're sort of made up of 2 back-to-back angle sections at the top and 2 at the bottom, with this cross pieces all riveted together. The steel is only a couple of millimetres thick. It's the angles are bent cold. it's very weak and quite a flimsy structure really. Usually in the roof there's not a problem. Same section is used for the floor joists and for the columns. The frames are generally at, I think, 1.2 metre centres. The investigations, we have to take out bricks. We generally select areas where it might be some damp issues, like a gully or somewhere. Usually have 2 or 3 locations as a sort of sample on it to see if there is any evidence of corrosion. This is a case where there was some severe corrosion. This is the 2 angles back to back. You can see how the steel work is all corroded out on that side and at that side. This one is being repaired. We've got a company who, it's the only people I know actually who actually specialise in doing repairs to these frames, and they'll give a certificate with the repairs. They basically weld in a proper solid steel angle to the frame there on a base plate. This is another location. At this location, this material here is, I think it's densotate, which they used to put on the outside face of the stanchions where the brickwork for the outer leaf is going to be pressed against it. But you can see the amount of steel which is rotted away in this case. The columns are seated on, this is an inverted channel section which is laid across the foundation, and then it's all generally concreted in. That was a particularly bad case in terms of the amount of corrosion there. A lot of cases you don't get any corrosion at all. When that repair is completed, that will all be reconcreted over, and anything sort of the top foot of the stanchion will be coated with a protective paint. This is another type of steel framed house. It's actually got steel cladding to the top, and the bottom is rendered on and sort of expanded steel lattice work. This guy's here is in the process of cutting out a bit of the render at the bottom of the corner so we can see the columns. It's a little bit more substantial, the steel work is. These are all hot rolled sections. These are tubular sections forming the trusses, and they've got angle sections forming the purlins. A little bit of surface rust there, but that is of no real consequence on that type of steel work because it's fairly solid. It's several millimetres thick. That's the gable end. We've got the angle sections there, angle sections, and that's the inside face of the outer steelwork cladding. This is the column which has been broken out. The column again is a hot rolled beam section, I think. Again, several millimetres thick, and even if we're starting to get some corrosion on there, it's most unlikely to have affected it to a degree of structural concern. It would, of course, need cleaning up and protecting against future corrosion. You can see there the original red lead paint, and there are some areas where some black bitumen is usually put on there as well to added protection at the bases. That is this sort of expanded metal which the render is on, which surprisingly is in good condition because it's a fairly thin coating of render, but it is painted on the outside, so that protects it well against the, let's say, carbon dioxide and acid rain, which would ultimately carbonise the cement in the render. This is the last one now. Not a structural problem. I just wondered if anyone's ever come across this one before. This guy rang me up and said, I've got holes in my roof tiles. I was a bit disbelieving. He sent me some photographs, and yes, there were some looked like holes in the roof tiles. I was still a bit puzzled by the whole thing, but he wanted a report so he could, because he was having a big argument with the tiling manufacturer. Went to the property. I could see he's very serious, looking at the amount of scaffolding he's got up there. There's obviously something issue going on. And it's just a sample. One of the tiles there, we've got live there, and looking at him close up, there are definitely holes in the surface, and these were dotted in the tiles all over the whole roof. Some of them to the extent that water was getting through the tiles, through to the sort of batten and felt zone, and he was really concerned about that in the long term. The tiling company, the tiling manufacturers, were not particularly helpful or cooperative on it. They obviously denied there was a problem, but yeah, he definitely had a problem. So I did him the report on it, giving all the details, etc. Again, it's another one, I don't know what the outcome was ultimately. I just wonder, anyone come across this problem before? No?
Not masonry bees, are they?
No, definitely not. No, that's not one. Okay, that's... I think that's the last one.
You're going to give us the answer.
Yeah. No, this is the problem. I mean, I do these reports, and the vast majority of them, I never hear anymore. I don't know what the answer is, what they've done. Did they buy the house? Did they not buy the house? Did they get a claim with the insurance company? I suspect in a lot of cases I recommend repairs, fill in the cracks or simple repairs, and it never gets done. Yeah. Any questions?
What did you say about the conservatory? Do you recommend the conservatory was demolished and rebuilt?
No, that one hadn't moved a huge amount. I was pointed out it needed underpinning. We'd have to do investigations because it was very likely that the underpinning, because of that tree was so close, that it would need to go down several metres. So we're probably talking about piled underpinning. Again, never heard any more from them. I don't think they got the money to spend on the investigations, and certainly wouldn't have had it to spend on piled underpinning for it. Maybe they went back to the people who built it. I mean, that should be their first point of claim, and they should have got really serious with those. But if they had, I'm sure I would have heard, because initially they would argue it's not our problem. We built it normal. And I would have been further involved in arguing the point. Yep.
With the steel framed houses,
Yeah.
what do you do in a sort of sale purchase or purchase situation? Because the owners don't generally like you going in, ripping bricks out and digging
Well,
up.
surprisingly, yeah, you're quite right. I mean, don't think I want people coming around pulling my house to pieces like that, but surprisingly, most people agree. I don't think I've had a case where they've said, no, we're not going to let you do this at all. I mean, the bricks are always put back pretty
You don't have
neatly.
any choice. You can't get a mortgage on it without having the certificate.
Yeah.
You can't get a certificate without doing the
Yeah.
inspection.
Yeah.
Apart from, there's an awful lot of engineers that still think an inspection of a metal building is to put an endoscope through at eye level.
Yeah, you can't see anything with those. No. Yeah. But yeah, if they want to sell, if they want to move, they're forced to it, I guess.
Any other questions?
Okay, thanks.